Welcome back. In the previous videos, we talked about Stealthwatch from the perspective of what comprises of the Stealthwatch system, and we talked about administering it. In this video, we're kind of going to dig into why we use it and what it does. So at its core, it's a network-based analytics tool specifically geared towards security. There's a lot of network engineer purposes you might want to use it for, but its core fundamental feature is how you can use it with security. So let's talk about the problem a little bit. Most companies, larger companies, have a lot of branches out there. They may backhaul some traffic to the internet through maybe a core data center, but as we're seeing, like the adoption of SD-WAN, for example, there's a lot more east-west traffic and direct internet access, and it's harder to have visibility onto from the endpoint perspective. And as we're seeing encryption happening, it's more and more, I think, like the encryption is year to date or year to year is just growing in terms of how much of the internet's traffic is encrypted. So how do you look at everything that's traversing your WAN or even east-west traffic without encrypting everything? It gets pretty expensive, and even then there's certain applications that you're never going to be able to decrypt. It's just not possible. So if you need to have visibility down to the access layer to see how, like, one user, this computer is communicating with this computer, how are you going to do that? So, there's some solutions out there where you can, maybe hang a IPS or some sort of tool off of a span port, but if you're trying to do that on every single access layer switch, it's going to get very expensive very quickly. You can also have some sort of network behavioral analytic tool spanning off of an egress point, or maybe have some kind of packet capture tool. But then you have to go and actually analyze that packet capture tool, which is both costly to have that level of storage, but it's also a lot of man hours to do so. So you need something that kind of automates some of these and lets you know when something's wrong, and maybe not save every single packet. There's certain legal issues that might happen. You don't want to be capturing the packet or decrypting your CEO's banking website data. And then, when in TLS 1.3, where SNI is hidden a little bit more, that might become more of a problem if you're trying to decrypt. So what Stealthwatch does is it gives you the ability to have the analytics down to the access layer and capture that metadata and see deviations from the norm. So the first thing it does is it looks for known bad. So, and it looks at over 100 different attributes for that, or algorithms. So what I mean by known bad, without even having visibility down to the endpoint, because there's going to always be 0-day exposures or maybe IoT endpoints that are compromised, that you don't have the ability to have AV on there, or there's something's just not going to get catched. Even if my AV doesn't catch it, let's say malware does certain predictive things regardless. So in one case, like the malware might try to reach out to the cloud and beacon saying, "Hey, I'm ready to be taken over as a botnet. Let me know," and it's going to just beacon. So that's one thing that Stealthwatch can look for, beaconing activity. Or once it gets down to the LAN and that this device is infected, it's going to potentially try to scan your subnet and look for anything, any subnet RFC19 addresses, and say, "Hey, I'm trying to find out what subnets are on this LAN," and try to infect other devices. So it'll scan, try to connect with SNMP, RDP, VNC, and reuse credentials to try to infect other devices. So what Stealthwatch can do is see that behavior and say, "Hey, this guy's scanning, it's looking for devices, it's trying to connect. Here's the bidirectional communication that happened. Here's which devices might potentially be infected, and let's go ahead and alert on that." So it gives you that visibility down to the access layer. Even without seeing what's on the endpoint, it sees that this is behaving really anomalously. It looks like it's malware. You should be alerted and be checking this out, because this host never should be scanning or VNCing to 100 different hosts, but it is. Deviations from norm. So norm is a perspective, obviously. One host or one file server or server application server might behave differently than another. So what Stealthwatch does is every single host it sees on the LAN, it starts baselining it. So it looks at 90 different attributes, and from time of day it's access, uploads, downloads, east-west traffic, relationship traffic between certain types of hosts. and it starts baselining it within the initial 7 days. After that, it's a rolling 30-day baseline, and it tells you can set a threshold saying, always alert me when there's over 100 gigs from these hosts to this group of other hosts. Or you can also say, but also alert me if there's a 50% deviation from norm for anyone. So it can look at thresholds and behavior and deviations from norm based on those things. And you can have both set at the same time. So that's how it kind of detects bad stuff. It looks for deviations from norm and deviations from norm and bad things. Now, segmentation is another big use case for Stealthwatch. So when it comes to policy creation, let's say you're deploying a network access control, and I'm not going to say ICE, just any network access control, or you're deploying ACI, NSX, whatever. You need to create the policy that's going to say, these hosts, these are the firewall rules, these are what applications or hosts need to talk to somebody else. How are you going to do that if you don't know what ports or what hosts they need to communicate on a daily basis? Well, if you ever ask an application team or even a desktop support team that manages the IoT devices, most of the time they don't know. They just go and look up. They might know the ports if there's a user guide for an application, but that's about it. So what you can do with Stealthwatch is you can capture the actual metadata of the traffic and where it's communicating with, and create an ACL or a security group policy, or whatever, however it is you plan on using these rules, and create it based off of the actual traffic that you see over like a 30-day period that these different hosts are trying to communicate with. The other thing is the assurance piece of segmentation. So what I say by this is, like, when people say our firewall rules are perfect, our ACLs are perfect, yeah, they might be, but it's a point in at that point in time, but it's always a point in time thing. So anyone who's a network engineer or ever worked as a network engineer and is watching this video has probably had a situation where there's an outage and you're troubleshooting it, and you make some changes to an ACL or you make some changes to a firewall to determine whether or not that was the problem. And if it's let's say the outage lasts 5 hours to determine a root cause, I dare someone to say that they've never had a situation where somebody has sat there and shot something, and they made a change and they remembered to go back and back out of every single change. It's pretty hard to do from a human perspective, and I've seen it happen. If it wasn't me doing it, having to go back and correct it, I've seen other people forget to do so. It's just human. We're human. We're flawed. It can happen. So what we can do inside of Stealthwatch is create rules saying, hey, if this subnet or this host talks to these groups of hosts, or maybe it talks to the internet, alert me, because these are our PCI compliance servers and they should never talk directly to the internet. Create a red alert for, if this thing happens. So it's just an extra level of visibility and alarming if something changes with what you have, with the controls you've placed in production already. Because at least with Stealthwatch alarming, there's no need to actually make any changes to that during troubleshooting, and you can sit there and have the assurance of being able to pull up reports and say, okay, our PCI servers are never communicating with the internet. We're sure of it. We have all the flows here, and it's always been stopped. Or if it happens, here's where we saw it happen, and this is the day that potentially that change happened. So that's another way of providing that segmentation and insurance piece of it. Now, forensics is the important part. Definitely. So with Stealthwatch, when it's capturing those flows, it does deduplication, where it takes the relevant data from all the NetFlow records it gets. It removes any excess records, and it takes what NetFlow is. It's basically a unidirectional conversation. So inside of that switch, it'll have one NetFlow record going this way for this communication, and it'll have another NetFlow record going this way. And it'll look like a unidirectional conversation, and for as long as this conversation takes place, it is going to, every active timeout period on this switch, it's going to send another NetFlow record. So during a 10-minute conversation, you might have multiple, NetFlow records for the same conversation, and it kind of gets redundant and hard to save this. So what Stealthwatch does is it trims down the crap that is redundant. It just kind of adds to the bit counts for the communication, and it deduplicates and it stitches it together as one bidirectional conversation in Stealthwatch's database. So instead of having a bunch of records using a ton of space, it has this nice, neat bidirectional communication record, like a flow record inside of Stealthwatch, and it's really easy to save for a longer period of time. So with that, you can, let's say you have an incident where you have to see, there was a host that was compromised, and you need to see everyone that accessed that host. You can sit there and do a search for like a host name if you have it integrated with ICE, and with that host. And everyone that was logged in using the username, not host name. So username, you can do a username search, and no matter how many times the IP address changed, you can see everything that, like, say, Catherine all the hosts that Catherine communicated with over the last 6 months, how much I uploaded, downloaded, what times I logged in and did those communications, and I can have it all in a nice, neat report. Or I can sit there and say, this is the IP address for this compromised host, and I want to go ahead and see everything that's communicated with it, and see every flow record of the last 24 hours, because we know it was compromised in the last 24 hours. And we can start to see, maybe build a picture of who reached out, connected to that host, infected it, or started moving data off of it, and where that data went to, and build kind of a timeline of what happened. So that's where the powerful forensics comes into play. And then the last thing is, if you have ETA encrypted threat analytics enabled devices, you can actually do crypto audits. So some of the things that allow ETA use of ETA, and that's where it looks at like the actual encryption in the packet and things like for those encrypted conversations. So the Catalyst 9000 series has ETA enabled. Certain ISR's versions of code will actually allow you to do it. And with that, it can capture that data and stitch that into the NetFlow data. So let's say you wanted to see which applications are being run east-west in your network that are running TLS 1.1 and below, because that's something that's a compliance issue and you need to correct that. You can sit there and do a search for everything that's TLS 1.0 or below, or 1.0, and have that listed out. See every conversation that took place inside of your network on using TLS 1.0. You can see who was the server, who was the user, and what ports were communicated on. And then from there, go ahead and correct or upgrade the application so you're in compliance once again. That's a good way to see when there's potentially vulnerable applications or ciphers being used. So that's another common use. There's a lot of things that you can use Stealthwatch for, but these are the common ones. So going through this, I'm going to kind of show you how the policy is constructed, what host groups are, different things like that. So inside of Stealthwatch, you can create a policy based off of a single host IP. That can be get pretty granular, but it's a lot of overhead work. So what we prefer to do, or at least we say we want to do, is if you have certain hosts, you put them in a host group, and a host group is similar to like an Active Directory OU. And you can assign policies based on host group. So let me go ahead and erase this really quickly and I kind of show you. So inside of Stealthwatch, there's an inside hosts group, inside hosts, and outside hosts. And there's a default policy applied to these default policy. And underneath that, there's kind of a tree. It's a hierarchical tree that of different host group types under that. So there could be like servers. There could be DHCP hosts. VoIP, things like that. And then outside host could be like divided by country, for example. There's a geolocation, like IP ranges in there. And you could also have something like outside host, like a trusted AWS range, where you can create a host group that, based on those AWS hosts that you're using in the cloud. So you can assign more granular policies to these host groups, and if you let's say you turn off certain alarms in that more specific policy to that host group, it'll still use anything that's not defined in that closer host policy from the default, but it'll turn off alarms or turn on alarms based off of what is the policy that's most closely aligned. So let's say you have the default policy is detect scanning. It'll check for scanning hosts and large uploads. But then you have a host group down here underneath the inside hosts that have for network scanners. And you decide to apply a policy that says, don't check for scanning. So regardless of what the default policy is, the hierarchical overarching default policy is, it will not look for scanning, but it'll still look for large uploads because you didn't define anything in regards to large uploads in that policy that you just assigned to network scanners. So if anyone's dealt with Active Directory, it's very similar to that. Active Directory, you have that default domain, and you have that default group policy that's applied to your AD domain. But then you have OUs underneath, like you might have the user OU, and then you might have your OU for computers. And you can assign group policies specific to this that override certain parts of the elements of the overarching default group policy. And that would only apply, it would only change the things that you defined that were different in the closer group policy. Very similar to that. And with that being said, I'm going to go ahead and jump into Stealthwatch, and I'll kind of show you around some of those different policies really quickly. So inside of Stealthwatch, let's go over to Configure and then Host Group Management. And as I showed you before, or as I talked about before, there's an inside and outside host group. So in this case, if I wanted to see some of the built-in host groups for inside hosts, you can see here that there's the client IP ranges, so the DHCP ranges. You can go ahead and put your subnets or specific hosts in for each of these. In this case, I think I put my domain controller in, as you can see here by editing it. I can also be very specific and say, send these flows to Cognitive Threat Analytics. That's the global threat analytics machine learning part in the cloud. And I can exclude them as well. So if there's certain flows that are confidential that even if they're in RFC 1918 addresses, I just can't share them. I can turn this off for this specific group policy, and at that point that the traffic won't be sent there. So I'm not going to change anything. I'm just going to cancel. I don't care about that. But this is how I would go ahead and add something to a host group. You've got these default ones built in, but I can add another host group if I wanted to underneath this hierarchy. And when I add a new host group, this is, let's say I'll just put one here for test server. I can enable baselining. If these are static IP addresses and I want them to be baselined, I would go ahead and make sure enable baselining is enabled. Disable security events using excluded services. So if I wanted to turn off certain security events based on certain services, I can do that as well here. Disable flood alarms and security events when this group is the host group is the target. That might be something that certain scanners, for example, would be. I wouldn't want them to be, something that we're going to do a lot of pen tests against, for example. And then that send flow to Cognitive Threat Analytics. I can put IP ranges. I can put specific hosts. I can put anything I want here. If I can import an IP range from like an Excel spreadsheet, or from just like a list. I can add that all in here, but that would be how I would create a new host group. I'm not going to do that here. I'm just this is supposed to be kind of an overview to show you how it's done, but we could get really into the weeds here. I just kind of want to give you the logic behind it. So it's a hierarchy, it's a tree, and some of the host groups that we might have, like in this case, I have trusted internet hosts, and AWS is my, I have an AWS list of trusted hosts that I want to turn off specific alarms for. Now, going over to the policy management, there's a couple different types of policies. So there's the custom events, and if I wanted to create a custom policy, I can name this something like SGT tag. And if I want to create something that's based on security group tags, like source and destination tags, and I can go ahead and start this policy. So the subject and peer tag, for example. I'm not going to do that, but just kind of showing you where that would start. TrustSec. So subject TrustSec ID, and then I can say 7, and then the peer one would be 8. Hold on a sec. Sorry about that. 8, 7. And if we can say that, we can say, do we want, always alert us when it's communicating on, a certain service, for example, HTTP. Apply. We could also do port rules. So subject port, port protocol. So we can, if it's something that's not a specific service that we know about, obviously 443 TCP is an easy one, but 443 TCP. If I wanted to say that I don't care as long as it's not a certain number of bytes, let's go ahead and say like anything greater than 500. So that can be like a custom alarm I could do. 500. Sorry, my wireless keyboard is having fun today. So that would be like a custom alarm I can turn on. Again, there's a lot of different options you can use for a custom alarm, and it tends to be like, look at what your security policy is or what you want to alarm on. The second type of is the relationship events. So this is between different host group types. So do I want to, I want to be alerted on certain, from inside, like one host group to another. So an example of this would be inside to outside. In this case, behavioral and threshold. So behavioral deviations and threshold is both turned on. So it's looking for deviations from like 50% or 50, and it'll never trigger alarm on less than 1 gig. I can also just increase that to like 10 gig, for example, if I don't care or if I want to make changes to that policy. And always trigger the alarm when it meets this threshold, no matter what the deviation is. And trigger an alarm when the duration is greater than X amount of time. So that's an example of a relationship policy. Now the next one is, I'm leaving the page, don't care. The next is the core events. Now the core events are specific security policies that are applied not between relationships, but specific to a host group. Now an example of this is like there's a built-in policy for network scanners. And we'll see that, you can see the inside host is the default policy. It applies to everything underneath. And as you can see here, address scanning is turned on. There's a lot of things that are turned on for alarms. But a more specific, like under the hierarchy, let's go back over here so I can help you visualize this a little bit more. So this policy right here, inside hosts, applies to inside hosts and everything underneath. But then underneath here, there's a network scanners group underneath inside hosts. And there's a more specific policy that overrides some of this stuff. And that's because network scanners will be really noisy and do a lot of network scanning. So in this case, address scanning and certain things are turned off for certain events. So even though the default policy applies certain things to this, because this closer policy is turning off certain alarms, it's not going to alarm every time there's an address scan from a network scanner group. So that's another security policy that's kind of built into Stealthwatch, but you can also add your own or create a new policy based off of a host group, or you can also do it off of a single host. But again, gets very granular. It's more of like a corner case type of thing, but just giving you ideas for what you can do.